Hi friends, nothing is impossible for those who dare to try. A sailor sees an iceberg ahead of his sailing route. Now, we're asked to calculate the volume of the iceberg submerged in seawater compared to the visible volume of the iceberg. This blue box represents a side view from the sea. The density of ice is less than that of seawater. When an iceberg is submerged in seawater, it will float. Part of the iceberg's volume will be below sea level. This volume is invisible to the sailor. Only the volume of the iceberg above sea level is visible. Let's start by identifying the forces acting on the iceberg. Objects with mass around the Earth are attracted to the Earth's center by gravity. Fluid particles will exert a vertical buoyant force upward. There are no other forces besides these two, so this seems easy. The iceberg is in equilibrium, meaning the resultant force acting in the vertical direction is zero. The buoyant force minus the gravitational force equals zero. Based on Archimedes' experiment, the magnitude of the buoyant force is equal to the mass of the displaced fluid multiplied by the acceleration due to gravity. The fluid is seawater. We don't know the mass of the object. What we do know is that it's equal to the object's density times its volume. VBF is the volume of the iceberg submerged in seawater. Because the shape of the displaced fluid volume is exactly the same as the iceberg below sea level. Similarly, the object's mass is equal to the iceberg's density times the iceberg's total volume. This value can be shifted to the right. The acceleration due to gravity can be cancelled out. From here, VBF is equal to the density of ice times the volume of ice, divided by the density of seawater. It seems all these values are listed on the worksheet. The density of ice is 900 kilograms per cubic meter. The density of seawater is 1,200 kilograms per cubic meter. This value is easy to calculate. VBF is equal to 0.75 times the volume of the iceberg. This means that only 25% of the iceberg is visible above sea level, with the remaining 75% below sea level. We are asked to calculate the volume of an iceberg submerged in seawater in terms of the volume of the iceberg that appears on the surface, not the volume of the iceberg as a whole. Of course, the volume of the iceberg as a whole is the sum of the volume of the submerged iceberg and the volume of the iceberg that appears above sea level. Simplify the values on the right-hand side. Collect them based on the same physical quantities. From here, VBF is equal to 3 times the volume of the iceberg visible above sea level. Happy learning, everyone!